Actually, well, you guys are in the middle of what is probably one of the most important and difficult decisions you've ever had to make, which is what and where to study at university. Now, not only is that oops. Oh, perfect. Thank you. Thanks. Not only is that a difficult and important decision, it's also very much a personal decision. So for what the right answer is for one person is not necessarily the right answer for the next person. But what is true for everybody is that you're more likely to make the best decision for you as an individual with the more information that you have. So the purpose of days like today, the purpose of talks like this, is for us to help you with that decision by giving you as much information as we can about, in this case, the physics programs here in Manchester. Okay, so today I'll be giving you information about what exactly that we teach on the physics program, how we teach it, how they structure the programs, what options are available, if you want to do things like spend a year abroad, for instance, and also talk about opportunities when you graduate, what careers are open to you. So this is all useful information, but it's not the only thing you can get out today, because it's also important to get a feel for a place. Is this somewhere you can imagine spending 3 or 4 years of your life? Okay, can you imagine learning in a lecture theatre like this? Or, and I encourage you to do this, if you go on the lab tours or the tours around the building of the physics department, you'll see our teaching spaces, our labs, our teaching labs, our tutorial spaces. Okay, you need to know that this is going to be a right fit for you. Okay, so take the opportunity to get a feel for the place, as well as listening to all the information I'm going to give you. And the other thing you can do today is part of the lab tours, where they're being given by some of our current students, our current physics undergraduates. So that's an opportunity for you to have a chat with a current student, get their perspective on what it's like to study physics here in Manchester. All this is going to be really useful information for you in helping you make that important, difficult, and personal decision. Okay? So, right, so I'll do my bit by telling you about the course and how we teach it and what you can do on it. I'll open for questions at the end, both to the audience, and I'll stay back at the end as well if you prefer to talk to me one-to-one. And of course, we've also, in the physics department, in the Schuster building, we've also got a stand where people will be there all day. So if you've got any questions that you have about anything you've heard today or anything that you've been wanting to know for a while, then please come and talk to us and we'll do our best to answer them. Okay? Right. Okay, so the first question we're going to answer is, what is physics about? Now, you've already got a good feel for it because you're presumably doing A-level physics at the moment. You're spending maybe a year or so, or maybe a quarter or a third of your time studying physics. But if you come to university, you'll be spending all your time for 3 or 4 years. So there's a lot more depth and a lot more breadth. So at university, what is physics about? Well, actually, that is the easiest question to answer, right? Physics is about everything. Everything. And I mean literally everything, because part of physics is studying cosmology. That's the study of the universe as a whole. So literally everything. Okay? But not just that, of course. We study physics, the world around us, the universe, at every possible scale. We study it as a whole, as an entire thing, as part of cosmology. We also study galaxies and stars and planets, like these astrophysical scales. We study things on the scale of ordinary human experience, things you can see and touch for yourself, but also study things that are far smaller than we can see. We study atoms and molecules right down to the fundamental particles, the very building blocks of the universe. All this is studied in physics. So physics is extremely ambitious, okay, in that it wants to understand the world, it wants to understand the universe at every possible level, okay? So its central goal is that fundamental understanding, but it's not the only goal. It's not the only side to physics. We also want to use that understanding to do useful stuff, okay, to apply that knowledge to make technologies, new technologies. So examples are by no means exhaustive that you've got here, things like nuclear reactors and semiconductors and body scanners and lasers. A great example, particular to Manchester here, is this one on the top right. This is a diagram of a device using graphene. Now, graphene, as you may know, is this wonder material. It's a 1-atom thick layer of carbon, which is the strongest and most conductive material ever discovered. okay? And it was discovered here in Manchester in the physics department, okay, in 2004, and the discoverers got the Nobel Prize for that in 2010. And that's a great example of how what was driven by just curiosity about the world and how it works is now being used in technology. We're using the fact that it's super strong and super thin and super conductive to make new devices, new electronics devices, okay? So physics is about seeking to understand at this very fundamental level the world around us, the universe at every possible scale. It's about using that knowledge to a useful thing, applying that knowledge. But it's more than that again. Okay, physics is also a method, our approach, a way of looking at things, a way of solving problems. Now, this is an example of what I mean. This is the Scholes-Black equation, right? And it won the Scholes and Black the Nobel Prize, okay? But they didn't win it for physics, they didn't win it for chemistry. They won this equation for economics. Now, this equation actually has its roots in physics. This equation actually was originated to describe diffusion. This is the process by which if I uncork a bottle of perfume over here, that smell will spread through the room, okay? It will diffuse to the room. So that is a physics technique, a physics method of describing that process. But what Scholes and Black did was they applied the same techniques to the diffusion of money through the economy. Okay, and that's why they got the Nobel Prize for economics. But it's a great example of how physics is not just about understanding the world, it's not just applying that knowledge, but also a way of thinking about the world, a way of tackling problems, driven by analysis, rigorous, robust reasoning, always referenced to experiment and the world as it is. Okay, so that's what physics is about. But physics isn't just something that you learn about. Physics is something you learn how to do, right? You learn to do physics. Now, what is involved in the process of doing physics? Well, physics is science, okay? Physics, that means that we always base our conclusions on evidence, and evidence gained through experiment, okay? So this means that you have to be very rigorous and robust in your reasoning. So Mother Nature, she doesn't care how clever you think you are. Mother Nature, she doesn't care how beautiful you think your equations are. Mother Nature doesn't care what you want to be true. Mother Nature just cares what is. Okay? So by doing physics, which is always based on experiment, Mother Nature makes sure your reasoning is absolutely robust and rigorous, because she'll tell you otherwise. Okay, so learning how to do physics is part of that process. You learn always how to do experiments, and because experiments by their very nature are something new, something that's never been done before, you need careful design and carrying out. Okay, so you do experiments, and then the result of those experiments is almost always numbers, data. Okay, now that on its own is meaningless. You've got to then analyze and interpret it and draw meaning from that data. That's another really important skill you need to do physics. And then you take that conclusion you've drawn from your experiment and then you compare it to what's already known. Does it fit with what we already know about the world? Or have we done something wrong? Or have we learned something new about the world? Does what we knew wrong? Okay? Now, supposing that we do learn something new about the world, it would be absolutely useless if we just kept that to ourselves. Okay? So another key part of learning how to do physics is communication, either orally by giving talks and lectures, or by the written word, when you write up your results as a paper or a lecture. Okay, so communication is also key. And also communication is important because these days, it's very rare that science is done by someone on their own in the basement, scribbling away. Okay, science is done in a team of people, and it usually uses expensive equipment, right? Which means you've got to persuade somebody to give you the money to do that experiment. You've got to persuade somebody that what you want to do is worthwhile and important. Okay? So learning how to persuade people is also a key part of learning how to be a physicist, how to do physics. So in learning how to do all these things, you develop a set of skills. which enable you to do physics, but as we'll see later, enable you to do lots of other things as well. Okay, and makes physicists one of the most employable types of graduates out there. So you learn to have that inquiring, creative, and critical mind. Is what we know about the world really right? Or is there some clues in the experiments that are telling us something's not quite as we think it is? Okay? And do I think that because I want it to be true, or because actually the evidence supports it? And as I said before, Mother Nature, she's ruthless. She will tell you if you're wrong, okay? She'll tell you through experiments. That means you get trained how to be very robust and rigorous in your reasoning. You learn how to be very numerate and analytical, okay? To draw meaning out of that numerical data that you've got through experiment. Okay, and you learn how to work in a group. Okay, so these days, it's almost always a team of people. So you learn how to work with other people, and eventually you'll learn how to manage other people as part of that team working. And also, at the end, you've got to learn to be able to communicate what you've learned, your new understanding, okay, either by delivering talks or lectures or by writing papers. So you develop a strong set of communication skills. Okay, so those, what I've said there is true about physics in general, but what about physics here in Manchester? So the home of physics is very much the Schuster building. Okay, this is just down around the corner from us. So this is where the vast majority of our physicists are based and our teaching is done. Okay, and it's been, we've had a physics department in Manchester for over 150 years. Right back to the time before people like Rutherford. Okay, and over that time, we've had no less than 13 Nobel Prize winners associated with physics as either staff or students. They started with people like Rutherford, who I mentioned. Rutherford was the first person to split the atom over 100 years ago, and he did it here in Manchester. Okay, and we've had a series of other Nobel Prize winners right up until our most recent two, back in 2010. We got the Nobel Prize for the discovery of graphene. Okay. Now that's an indication of, one indication of the quality of the research here in Manchester. But what about, well, a very recent result that is, indicates how good the research of physics research here in Manchester is what's known as the REF21 exercise. This is the Research Excellence Framework, it stands for. This is an exercise carried out by the government every 7 years or so, where it assesses the research in every department in every country. And these are the results for physics. Okay, and as you can see, it rates all the research it does either as world leading, internationally excellent, recognized internationally, recognized nationally, and ranks them in this way. And you can see that Manchester is the highest ranked on this table. Okay, so that's important. Why is research important from a student's point of view? Well, one of the benefits you get as a student of coming to learn in a research university is you get to learn about the latest results in physics, latest discoveries in physics, by the people making those discoveries. So we get that quick feed through from the latest research into the teaching. So I mentioned graphene before. So even before the Nobel Prize was awarded, we were using graphene in the teaching. We were talking about it in the lectures, we were using it in the lab experiments. You'll see, if you go on the lab tour, you'll see how we're using graphene in the undergraduate lab. So that's the benefit, from a student's point of view, of coming to a research university. A quick feed through from the research into the teaching. Okay, so what's the physics? That's about the research at Manchester, but what are in terms the departments like in terms of the people? Well, we're a big department, big-ish, not the, maybe about the third or fourth biggest in the country. We have over 90 academics, so academic means either a lecturer or a professor. So the people actually teaching you. And they're supported by over 200 other staff, such as admin and postdoctoral researchers. And we welcome about 330 new students to us every year, and about 70 new postgrads. That means we're a big department. It means, because we have these 90 staff, that we've got a wide range of expertise. So one of the benefits of a big department is that you can if there's any particular bit of physics that you're most interested in, we've got an expert in that area who can lecture a course in that. Okay? The other benefit of having so many staff is that even though we have 300 students, we can still have small group teaching, particularly in the form of tutorials. So a tutorial, if you're not familiar with it, is you have a class of 4 or 5 students and a member of staff where they talk about what you've been learning in the lectures in depth. So some of the stuff you'll learn about is very challenging, difficult concepts. We talk about relativity and quantum mechanics even from the first term. So we think you really benefit from that experience of being able to talk over these difficult ideas, these difficult concepts with a member of staff in a tutorial. Okay, here's some more shots of the inside of the Schuster building. You'll see this if you go on the tour. So that's the Schuster again. This is the new annex. This was built about 5 years ago. This is, I think it was about £10 million. This is a sign of the investment the university's placed in the teaching of undergraduate physics. This houses our first year teaching labs, for instance. The physics department has outgrown the Schuster building a little bit in terms of some of our staff, particularly the astronomers, are based in the next door building in Turin. Okay? And these are shots within the Schuster. You'll see more of that if you go on the lab tour. Okay, so now I'm going to tell you a little bit about the various options that we offer, the various programs. Okay? We have a number of programs, most of which can be either taken as a 3-year bachelor's degree or a 4-year MPhys. Okay? Both are undergraduate programs. Now, there's no hard and fast rule about which of those you should take. Okay? But as a rough rule of thumb, I would say that if you want to study physics at university and then go off and use the skills rather than the knowledge, then maybe the BSc is best for you. Or in contrast, if you want to use the skills and the knowledge, maybe you'll benefit from the extra year of learning involved in an MPhys. Okay. However, having said that, it doesn't really matter. You've got to put one or other on your UCAS form, either bachelor's or MPhys, but those two programs are actually the same for the first 2 years. And so you can switch between them until the end of your second year. In fact, what we do is we write to everybody towards the end of the second year saying, what do you want to be on? Do you want to be on the bachelor's or the MPhys? Okay. Now, those are the two broad categories of degree, and then we have variations. We have things like physics, okay, and physics with astro, or physics with theory, physics we study in Europe, and maths and physics. The ones that are, say, physics with something, that means you spend about 2/3 of your time doing the physics and about 1/3 of your time studying the other subject, the astrophysics or the theory or the study in Europe. And we also have maths and physics, which is a true joint honours. It's a 50-50 split between those two subjects, and it's taught jointly between ourselves and our colleagues in the maths department. The only degree there that's not offered as a BSc is the study in Europe option. That's because you spend the 3rd year of 4 studying at a part university overseas. Okay, so it can only be part of a 4-year program. Okay, so first, and I want to talk a little bit about entry requirements. Our standard grades, standard entry offer is A star, A star, A, with the A's in physics and maths. The 3rd A level can be anything except general studies. If you're studying 4 A levels, then we take the maths grade, the physics grade, and the best of your other 2. Okay, so we do it to whatever advantages you. Now, obviously that's a very high offer, so I'll explain why it's so high. Under the UCAS system, if we or any department around the country makes you an offer and you get those grades or better, not only will we accept you, we have to legally accept you. We cannot say no, right? And because we get about 1,800 applications for just over 300 places, the only way we can control numbers, because we only have so much space in lecture theatres, and in particular we only have so much space in the labs, is by setting the offer grade at that level. Okay? So really it's a function of supply and demand. It's the only way we can control numbers. Okay, so that's our standard offer. We do reduce that a little bit for those give what's known as contextual offers. Those are people who from backgrounds, maybe from postcodes that don't generally send many people to university. So more details about what's involved in that are all found on the website. But our standard offer is A star, A star, A. Okay, so that's information about the programs in general. Now, in terms of what we teach, in terms of subjects and topics, now, our course is accredited by the Institute of Physics, which means that we have a certain number of topics that are included as core, essential material. These are the topics that every physicist should know. So they include things like quantum mechanics and relativity and particle physics, okay? But that doesn't take up the entire timetable. So the rest of the timetable, so you're doing 120 credits in any year, roughly 10 credits per lecture course. So the credits up to 120 are made up to by choosing options, okay? As I said before, one of the benefits of coming to a big department is that we have a wide range of expertise, so we can offer a wide range of different lecture courses, options. Level 1, Level 2, Level 3 corresponds roughly to Year 1, Year 2, Year 3. And you see that the range of options increases as you go from through the years. This is because in the first year or two, you're covering all the essential material. By the time you get to Year 3, and especially Year 4, you've covered all the core material, so you're then free to choose options, bits of physics that you want to study. Okay, so that's years 1, 2, and 3. This corresponds to both BSc and MPhys. If you're on the MPhys and you've got a 4th year, then there are no core lecture courses. Okay, it's all options. You choose 8 different lecture courses throughout the 4th year. That list is far too long for me to read out, but you can see it spans everything from advanced quantum to galaxies. And that's just the courses that we offer within physics. You're also able to take courses from other departments. So if you want to do a bit of maths or engineering or a foreign language, you can do that as well. The only core element, if you like, of the 4th year is that everybody does a research project. Okay, so you spend 2 days a week for the entire year embedded in a research group, okay, doing research, and that makes up about 1/3 of your credit for that year. Okay, so let's talk about, that's what we teach. Let's talk about how we teach. So it varies a bit as you go through the 3 or 4 years, in the sense that, for instance, the 4th year, you're doing a big research project, which takes up more time, so you do less lectures, etc. But to give you an example, let's talk about the first term of first year. So this is what you might be doing if you come to Manchester in your very first weeks with us. Okay, so in that term, you're doing 5 modules, 5 lecture courses, each of which has 2 hours each. So that's 10 hours of lectures in a lecture theatre like this, being lectured by someone like me. You also have a day in lab. That's about 5 hours. Okay, and then you have 2 separate hour-long tutorials. Okay, so as I said, we're very keen on tutorials because, you know, physics has got these really quite difficult and challenging ideas. You know, we're talking about the nature of space and time and reality, and we think you really benefit from having the opportunity to discuss those in depth with a member of staff. So we're keen on the tutorial system. So all that adds up to 17 hours of actively being taught in person, in a room with a real person. On top of that, of course, you're given some homework. So you're generally given problem sheets to tackle based on the lecture material you receive that week. And the lab work you do is often, you need to write up reports about that as well. So it's a full week's worth of learning, with the exception is that we always leave Wednesday afternoon free. Okay, that's the same true across the university. That enables you to get involved in student union activities, sport, whatever it is. Okay, so it's 4.5 days learning a week, if you like. Okay. We're keen to make sure that everybody who comes to us does as well as they possibly can. So we have a number of systems in place to support students in their learning. Probably the most important is actually the tutorial system itself. This means that you're regularly meeting once a week with a member of staff at a scheduled time. So they're the first person you can talk to if there's anything getting in the way of your studying. Okay? They might not be able to solve it themselves, but they'll be able to point you in the right direction. Okay? So the tutorial system itself is an important way we support students. We also have what are known as academic advisors. Now, you meet your tutor once a week to talk about what you're studying in particular, but you also have a second member of staff called an academic advisor, where you meet maybe 3 or 4 times a year, and their role is not to talk about what you heard in lectures last week, but rather to take an overview of your progress, to look at your exam results, to help discuss lecture option choices, and talk you through all the options you've got as you progress through the 3 or 4 years. And they stay with you for the entire time you're in Manchester, so you have an overview of your progress as you study with us. We also have what's known as the peer-assisted study sessions. So basically, when you arrive with us as a first year, you're given a buddy, if you like. So this is a student in an older year, which allows you just to talk to someone who's also a student on an informal basis, which might, for some cases, you might prefer than talking to a member of staff. So we have various ways in which we support you. And of course, we're a big university. We're very used to supporting students who might have some kind of disability. So it could be physical, it could be learning. So for instance, if you're dyslexic, you get more time in exams. You'll be given printed out versions of the notes, so you don't have to take things down in lectures. Okay, so we're all got systems in place to support you to make sure you do as well as you possibly can when you come to study with us. Okay, so let's imagine that I've persuaded you of the wisdom and excitement of studying physics. And in particular, you're keen to come to Manchester and you get the grade and you come and you spend 3 or 4 years of your life having enjoyed yourself talking about Higgs bosons and black holes and all that sort of stuff and graphene, and then you graduate. What then? What sort of careers do our students go on to? Well, I'm going to do, first of all, give you a couple of case studies and then I'll give you some data, okay? Because as a scientist, I like data, okay? Data is good. But the case studies first. So these are recent graduates from our programs, and they illustrate the sorts of things that people do. So this is Ellen. She did the physics with astrophysics and phys, okay? And as you can see, after graduation, she ended up working for Apple, okay? So this is illustrates one major route our graduates take, is where they're using not necessarily the physics knowledge, but rather the skills they've learned. Okay, so this is things like the numeracy, the analysis, the ability to handle data, okay? And then gone to work for a big tech company. Another example of where someone's using, excuse me, both the skills they've learned and also the physics knowledge, okay? This is Cayman. Cayman actually was a student, undergraduate, who did his research project in his 4th year with me. So that picture you can see there is taken at a conference. So we were lucky enough that Cayman's results were good enough to take to an academic conference and resulted in a journal publication. And he went on to work for a publisher, an academic journal publisher. So when you submit a physics paper, you submit it to a journal, and it gets assessed and rated by an editor and referees before being published. So Cayman's working for a physics journal doing that. Okay. Now, this data is based on the Delhi survey. Delhi survey, again, is something that's conducted by the government, and basically they write to 6 months after graduation to every new graduate and say, what are you doing now? Okay, and they compile the data for the various programs. So this illustrates roughly what our students tend to do. So we've got, I split it between BSc and MPhys because they tend to behave a little bit differently, and also horizontally by a broad category of what they're doing. So the top row is scientific technical computing. So this is working for tech companies, for instance, where they're using both the knowledge and their understanding and their skills as well. So as you can see, more of our MPhys students tend to do that, and a few of the BSc. And in contrast, the middle category, which is finance, and so this is clearly where people are using not the knowledge per se, but rather the skills, particularly the numeracy and analysis. It tends to be the other way around, so more of our BSc students go down that route, and fewer of our MPhys students. And the last category on the bottom here is people going on to further training. So particularly PhD is the biggest category there. So we get some of the most highly qualified students coming to us. It's not surprising that quite a lot of them want to go on to postgraduate study, PhD study, in particular both here and elsewhere. Okay, now the other thing I wanted to show you today was this report, which was actually written by the Institute of Physical Studies and published about 4 years ago now, nearly 4 years ago. Institute of Physical Studies is a respected think tank, and this report was commissioned carried out by them, but commissioned by the Department for Education, which looked at the relationship between degree subject and average earnings early career. So I'll show you two graphs from that report, one for men, one for women. They look very similar, but you can see what we've got here. We've got degree subject on the bottom, and we've got average earnings at age 29 on the left-hand side. So notice where it's ordered from low to high. So notice what this end, what the, if you like, the high earning subjects are. What's the common link? You've got things there you might not be surprised to see, medicine, law, but you've also got economics, maths, physics. The common link between those, numeracy and analysis. So those are the skills that physicists learn in the lab, okay, taking that experimental data and analyzing it and interpreting it, drawing meaning from it, making decisions based on it, right? And those are the skills that can be transferred to things, other things, such as analyzing stock market data or a business spreadsheet. And that's why those skills are in such demand by employers. Okay, this is the data for women, very similar looking. In fact, physics is even higher up this scale. Okay, but the picture's the same. Okay, so the skills you get when you learn how to do physics, when you study for a physics degree, are in high demand. Okay, the analysis, the numeracy. Okay, and that's what means that physicists can have a range of career opportunities and demand a high salary. Okay, we've got a career service I want to mention as well, which will help you prepare for your transition to the world of work. Okay, we've got do things like information about different employers, the milk rounds. We'll give you training on how to do interviews and psychometric testing, etc. And also, you have access to this, of course, when you're studying with us. We also allow you, we don't just abandon you when you graduate. You can have access to all this for a further 2 years after graduation. Okay, so we're really trying to help you that transition from study into work. Okay, to sum up then, physics is very ambitious in its scope. We seek to understand at a fundamental level the universe at every possible scale. We also seek to apply that knowledge to useful things. And more than that, physics is also a mindset, an approach, a method about how to understand the world, how to tackle problems, okay, which is very powerful. And as when you study physics, when learning how to do physics, you develop a set of skills that are really useful, that can be used within physics or actually in a whole range of other areas, which means that your skills as a physicist are in demand, which helps you in your transition to the world of work and get the career that you want. Okay, before I finish, just to flash up that you'll get a chance, if you want, to talk to some of our current students as part of the lab tour. Okay, they're all current physics students, so you can talk to them about what it's like from their experience. If you don't get a chance to do that today, or you have some question you want to ask them at a later date, then you can chat to them through this website. It's basically like a WhatsApp type chat function. You can talk to a real student about what their experience of studying physics has been. And also, if you have any other questions today, so I'll take questions in a moment. We have the stand in the Schuster Building lobby all day if you've got any questions. But if your question only occurs to you on the way home today or next week or next month, then please, we'll do our best to help you. Just send us an email or look on the website, and we'll try and give you as much information as we can. Because as I said at the beginning, this is all about us helping you with this difficult and important and personal decision, which is what to study university. Okay, so I'm happy now to take any questions you might have. I will open up to the audience now. I'll also take questions one-to-one at the end if you prefer. Who's brave? Yes?
Are you put at a disadvantage if you don't do A-level further maths?
No. So we ask for A-level physics and A-level maths, but nothing beyond that. So we only assume you have A-level maths knowledge when you come to us. Okay? And in fact, the first term is making sure that we'll basically everybody's starting from the same mathematical basis. So, no. Yep, you at the back. Small group, so that's 4 or 5 students and a member of staff. Yeah? Yes?
That member of staff, is that the tutor who's teaching them? Is it a postgrad? Or, you know, what's
We have a member of staff, like me, I do them, for instance. So in the first year you have 2 tutorials, one of which was a member of staff, and the other one was the postgrad, okay? But you always get one with a member of staff. And the second year, you've got one with a member of staff as well. Yeah. Yeah.
While we're doing the course and say we're researching something, how does the university support?
So can you just say that again? Quite
If we're doing the course and we also want to research or do a project of our own, does the university help in that?
So the way if you're very keen on research, excuse me, principally the research project you do in year 4 is basically a third of your time embedded in a research group. Okay. If you want to get into research before that, then we have a number of research internships you can do during the summer. So you apply for that, and we pay you to do it as well. Okay. It's competitive, but we have some internships to do in the summer break. Okay. We don't want to overload you with stuff where you're supposed to be studying your lecture courses, but there's an internship. But principally, the MPhys project is a research project, which is a full 1/3 of your time in year 4. Yeah. Right, okay. Yeah. So, it depends on what level of language you come to us with. Yeah, so when you go abroad in year 3, you'll be learning physics, but in a foreign language. So we need to ensure that your language skills are good enough at that stage for you to learn physics in French or German or Spanish. Okay, so how many lecture courses you need to get yourself up to that level depends on your language knowledge when you come to us. So what happens is that when you arrive, the first week or 2, you're given an assessment of your language level by the language school, and from that point we design a set of courses that make sure you get to the right level by the end of year 2. If you're fluent already, then it will have no impact on what options you can take. If your language level is quite a bit below where we need it to be, then we're going to require you to do language options to make sure that you're able to be fluent by year 3. Yeah. Okay. At the back, gold and green. So you do core material in both. The major difference between maths and physics and just physics is that you do half the amount of lab. So that roughly day a week that frees up for half the time means you can do both core material and some options as well. But it has to be said, you have fewer option choices than if you just did physics, because you have to do core material in both areas, but there are still some. That side?
Besides the grades, what other evidence do you use to assess who gets the place?
So the single best predictor of people doing well on our physics program are A-level grades. So we will interview you, okay? And the way we use interview is that if your predicted grades match what we require our entry grades, they will make you an offer. And if you get those grades in the summer, fine, you got placed, no question, right? But because we aim not to overfill the course, so we aim to undershoot a bit, to give ourselves a safety margin, sometimes we have places left. Now, we will then aim to take as many people as we can who've just missed out by a grade to fill those spaces, right? there will often be more of those people who've just missed out by a grade than are places left. And in that case, we will look at the interview transcript. Yeah? The interview will be asking you questions about physics and maths. Okay, so principally the A-level grades, but if you just fall short in the summer when you take exams and there are some spaces left, then we look at the interview transcript. Yeah, yes?
What's the split like between girls and boys?
26%. Yeah, which is a little bit more than the fraction taking A-level physics. So we can only match the grades for the pool from we're taking from. So, yeah. Interestingly, it's 33% at PhD. Okay, so it's good to do physics. Yes?
So you're not actually that interested in personal statement?
If you're captain of the cricket team, or you've done DOV, or you've speak German, that's great for you as an individual, but it says very little about your ability to do physics. Yeah? So we base our decisions based on the best evidence we have that predicts how well you will do on the physics course. And unsurprisingly, that's A-level grades. Yeah? Yes?
Are EPQs considered in the admission?
No. 3 A-level grades, maths, physics, and a third. Yeah, that's what we consider. Yeah. Yes, sorry.
How flexible is it to switch between the physics and maths? Physics choices, and that has to be a bit of
So it depends when, okay? The entry grades are the same, entry requirements are the same. There's no quotas, okay? So after you've applied, if you want to change your mind, you just email us and we'll just switch on the UCAS system. Even on the day you arrive to start, that's true as well. And it will become possible, or it's also possible as you progress through the first year, but it will become progressively more difficult because if you switch, you'll have to be able to catch up the stuff that you've missed. So up until the day you start, no problem at all. Possible probably through the first year, but it depends how far you got through. Yeah. Yes?
Are the entry requirements the same for the BSc and
Yes. The entry requirements.
any numbers, caps on either of those? Or
No. The entry, there's no caps on either BSc or MPhys or particular degree programs, physics, astro. The numbers vary in each of those from year to year, but not much. And there's no caps. So there's no tactical advantage about going for one or the other. Yes?
What's the acceptance rate for BSc? Is it 8 to 1?
Well, we don't think of it in terms of for BSc or MPhys because those people could change, they could swap between them up until the end of year 2. So we just talk about the whole intake. So it's about 1,800 applications we get, and we get about just over 300 people, new people coming to us every year. So it's about 6 to 1 on that basis. Any others? Oh, sorry, I couldn't see you there.
Is it possible to transfer from math and physics to physics or vice versa?
It is basically what I said before, in that until the day you start, trivial. Right? Well, actually, if you'd applied for maths, I think the entry grades are slightly less. So it depends if your grades are the matched hours, if you're swapping to physics. And if you wanted to swap from maths and physics to maths or to physics, it's possible, even if you've started in the first year, as long as you've not gone too far down the track and you can catch up what you've missed. Yeah? Yeah, behind. No. So we have a formal program which has year 3 abroad at a partner university in France, Germany, Spain. Because that involves language learning, so you have to be fluent before you go, that's a formal program. However, we understand that some people want the life experience of going to live and study abroad, but don't want to have to commit to learning a language to that level. So we also have a similar program for spending year 3 abroad in an English-speaking country, so Australia, Canada, and the US, with most of our students going to Berkeley in California. Okay? Because that's no requirement of language learning, we just basically ask everybody in year 2 who would like to spend year 3 abroad in an English-speaking country. And then you make a decision then. The only requirement is that we don't want you to go unless you're getting at least 50% exams, because it will be more difficult to uproot yourself and go to a different foreign country and settle down. So if you're only just managing, then we'd think maybe stay where you are. But if you get more than 50% of your exams, and then if it's the second year, then you can spend year 3 in Canada or the US or Australia. But you don't have to make that decision now. You can do that. That decision's made in year 2. Yes?
Does that year count towards your degree?
Yes, yes. So you're studying physics whilst abroad, yeah, and it counts, yeah. So it counts. So that you take lecture courses, you take exams, and those exams are basically count towards your degree here in Manchester.
Does it add a year on?
No, it's instead of the year 3 you would have spent in Manchester. Girl in purple, yeah. Yes, we do have a secondment scheme. Well, in contrast to what I've just said about the year abroad, studying abroad, this actually adds an extra year into your program. So if you're on the BSc, it will be between years 2 and 3, and then you'll be spending, so your total degree will be 4 years, which you spend a year out. And similarly, if you're on the Phys, it could be between years 2 and 3, or 3 and 4, and it would make the whole thing 5 years long. Yeah. Yes? Yeah. It's about 25 to 30, that sort of size. Oh, yeah, sorry. So the vast majority of our lecture courses are assessed by a formal exam, either in January or May, June. Okay, the exceptions to that are lab. That's assessed by a mixture of an interview and a report. There are 1 or 2 exceptions, like there's a programming option you can take, and that's a coursework. But the vast majority of lecture courses are exam. Yeah.
Is it like 2 exams over the year?
No, you do 1 exam per lecture course. So the example I gave before is in first year, first semester, you do 5 lecture courses. So you have 5 exams in January. Yeah. Yeah, that side.
Depending on which specific kind of physics, like theoretical or academic, you choose to take, will you have different restrictions on what you can do in certain courses?
So some of the courses that we do are you have to build up. So you have to have done a course in second year, for instance, to be able to do a course in third year, to be able to do a course in fourth year. So there's that restriction. We don't have any other restriction in terms of what courses that you do. So there's some core courses that you've all got to do, and what counts as core is influenced by which program you're on. So if you're doing physics with theory, for instance, you'll have something as core, which is not core for someone on the regular physics. Yeah. But someone on the regular physics can opt to take that course, which is core for a theorist. Yeah. Yes?
How much of the time is spent writing lab reports? Do you get any help from that?
Yeah, well, obviously you're given, you're told what's expected, you're given lots of guidance, given a sort of a introductory lecture about what's expected, and you're given feedback. And also, obviously, it's meant to be a learning process, so you're given lots of detailed feedback about your first one, and it's not marked as critically, and then you're supposed to learn from that process. Yeah. Yes?
Details in your placement programs?
Oh, in industry?
Yes.
Yeah, so what we do is we help the students arrange a job placement for a year. So it could be within industry, or it could be with another big employer like the NHS, for instance. And so they basically interrupt the degree program and then spend a year working, get the experience, and then come back. So examples of people who've employed are NHS, or there's Thales Optronics, which is a defence company. Other ones, the Rutherford Appleton Lab, which is a government research lab down in Oxfordshire. That's another example. Okay, so they work there for a year, sorry. Oh, in terms of people doing it, so actually, it's only about half a dozen a year opt to do that. More could do it if they wanted to, but we find that about 6 people. I think part of it is driven because you add an extra year to your course, you're getting out of sync with your friends. I think that's the issue for some people. Yeah.
I missed the deadline for access to Manchester. Is there anything else that's sort of like that which might reduce your offer?
So we have what's known as contextual offers. So when your application come in, it gets assessed against lots of criteria about whether you come from a postcode that is hasn't sent a lot of people to university in the past, or if you spent more than 3 months in Kerr and things like that, and then that reduces your offer to different levels. I think there's 3 steps to it, with the lowest, so that, the one that meets most of those criteria being reduced all the way down to 3 A's. If anybody's holding a hand up and I haven't seen them, please wave vigorously. One down there, sorry.
What kind of elements is programming in the course? Is it part of the core modules?
We have one core course on programming that we do because it is a useful skill to know in terms of data handling. It's using Python, I don't know if you're familiar with that. There are other programming courses that you can choose to take as an option, but they're not core, they're not compulsory. Yes?
Is it possible to take optional modules outside of the physics?
Yes, absolutely there is. Yeah, you can teach, there's a whole bunch of courses you can take from other departments, or even a set of courses you can take which are designed to be taken by anybody. So they're not associated with a particular department, they're just a generalist's course on, I don't know, world affairs or something like that. Yes?
For the study abroad in an English-speaking country, what kind of percentage of students who want to do it get to do it?
So like I said, the only restriction is we ask you to be doing getting at least 50% in your exams after the end of year 2. The number of people who tend to actually go and do it is about, it varies from year to year, about 10. Okay, but that's, again, I think some want to do it, others want to keep in with a group of friends and a cohort. I guess that's the tension, isn't it? Oh, yes, sorry.
Does the physics course assume any prior knowledge with programming or computer science?
No. Oh, the only prior knowledge we assume is A-level physics and A-level maths. Yeah? That's a starting point, right? We take everybody from then. Oh, yes?
So if you accept 300 people in class, you accept
Sorry, can you speak up a bit? I can't quite hear.
If you accept, so let's say if you accept 300 people into the course, what proportion of those have done A-level further maths or AS further maths?
I would say probably, off the top of my head, about 10%. But it's not, like I said, we don't assume you've done further maths. So you're at no disadvantage if you haven't done further maths, I would say. Okay. Conscious of the fact there's another talk on in 4 minutes in this lecture theatre. If you've got any other questions, please come and find us in the Schuster building. We've got lots of people there available to answer questions. If I'm answering. Okay.